My work with Ultranova continues, and in this video I'm going to show you how I created this nebula in Blender to be used as a sky sphere, the planet, atmosphere and procedural asteroids in Unreal Engine. And I'm going to show you how I modeled the interior of the Reaper spaceship in Blender. Later in this video I will show you how you can animate these types of lights with a simple material, but first let's have a look at how a super noise nebula was created in Blender. Making video games is so creative and I'm having a blast making Ultranova and learning Unreal Engine in the process. Speaking of making games, every serious game should have its own website, which brings me to the sponsor of this video. Back in the day I was obsessed with finding the .com site, but most of the time the domain would already be taken. And more often than not, nobody was using the site. It was just registered by someone hoping to sell the name to make a profit. When we got linewar.com, it was parked by someone and we had to pay a high premium to get it. That's not fun, but I'll tell you what is fun. You can get a .fun domain name instead, and if you go to www.get.fun and use the discount code Ultranova, you can get it for 99 cents in your first year. How cool is that? So you have a super affordable way to get your game's new unique .fun domain name. I just launched Ultranova.fun, which is home to Ultranova. This way I can have more information towards my game and a super clear directory for other development videos I have. You put a lot of time and effort into making a game, and creating a home for the game away from store pages like Steam can drive more traffic and players, and it shows you are serious about your game. You have more freedom to post news and multimedia, collect subscribers to newsletters, publish links to different storefronts where you sell your game, host leaderboards or content, or even set up your own payment processing and sell the game directly to the player. So head over to www.get.fun and use the code Ultranova and register your new .fun domain name right now. In the intro cutscene of Ultranova, I need a space scene in Unreal Engine where the Reaper spaceship gets into an asteroid storm and plummets down to the surface of a planet. I wanted to create a nebula for a backdrop, and it turns out that you can create a pretty cool immersive nebula in cycles in Blender. This single volumetric material in Blender, assigned to 6 primitive cube volumes around a camera, generates a highly detailed nebula. It requires cycles to render and it's slow, but when you give it some time to render, I think the result is pretty convincing. I put a bunch of point lights inside the cubes to light up the nebula, and I had to modify the volumes settings where I changed the step rate down to 0.01 and max steps to 256, which significantly slows down the rendering, but it provides intricate details in the gas clouds. The key to the volumetric nebula is the so-called super noise, which is generated by 2 3D or 4D noise texture nodes, where the color output of the first one plugs into the vector and the scale nodes of the second texture. A color ramp is used before it's plugged into the scale node, and different noise texture settings can be tweaked. Cycles can render equirectangular panoramas, which squeezes everything around the camera into a texture similar to how a world map contains the planet continents on a rectangular image. This maps perfectly to a sky sphere inside Unreal Engine, and I need to continue to tweak my settings to get the type of nebula environment I want, but it's a great start. When you use denoising in Blender, it breaks the perfect seamless wraparound, but it's pretty easily fixed in something like Photoshop or Krita. Compared to Unity, Unreal Engine supports massive worlds. A realistic max size in Unity world is about 10 kilometers in any direction, because Unity uses vector 3 positions with 32-bit floating point values, which start to lose precision when you get beyond 10 kilometers away from the origo. Objects will begin to skip around and jitter if they're far away, which is why you'd normally have to either move the entire world around the player, where the player is always in origo, or you have to snap the player back to origo and move the entire world to compensate if the player gets too far away. In Unreal Engine, since version 5.1, double 64-bit precision values are used instead by default, which means it can support huge worlds without losing precision. Before 5.1 you had to enable large world coordinates, but nowadays it's enabled by default. In Unreal Engine you can now go 44 million kilometers away from origo before you run into any precision issues. It turns out that I could create a planet that is 2,000 kilometers in diameter, which is about 6 times smaller than Earth, and still position my 700-meter Reaper spaceship far away from the planet and create a timeline sequence to animate all the action that takes place in space and follow the Reaper spaceship as it plummets down to the planet's surface. In Unity, I created a procedural planets asset, which is used in an upcoming indie game called Falling Frontier, which has been in development for about 5 years. It's a highly anticipated space strategy game, and I'm thrilled that some of my work is in that game to render the planets. I had to write shaders to create atmospheres for those planets, and this is another area where Unreal Engine has an edge. The SkyAtmosphere feature in Unreal Engine is most commonly used to create an atmosphere in ground-based games like first-person shooters. This atmosphere simulates how sunlight behaves with Rayleigh scattering and Mie scattering. This is why you get the nice orange sunsets and the blue skies. The beautiful thing is that the SkyAtmosphere component also works on a large scale, and if you set the radius of a planet, you can zoom out and the atmosphere wraps nicely around the planet. I should also mention that to get the seamless transition from space to the planet's surface, I have to apply two console variables: r.skyatmosphere.aerialperspective.lut.fastApplyOnOpaque 0 and r.skyatmosphere.fastSkyLut 0. CVARs are not saved in Unreal Engine, so I put them in a level blueprint to execute a sequence in the event begin play. As the Reaper ship enters the atmosphere, I want volumetric clouds. Again, Unreal Engine comes with cool volumetric clouds out of the box, and they are generally only used as viewed from a planet's surface. They look too repetitive and they don't support the view distance to be viewed from space, and even though they do wrap around the planet's surface, they break around the equator a little bit. I will make a camera cut to a lower altitude where the clouds become visible, so for my purpose, they should still work. In space, I need asteroids and a PCG volume, or Procedural Content Generation Volume, where I've created a spline and a blueprint that scatters instances of asteroids around the planet. This is a performant way to create many objects, and the position offsets, size and rotation of the asteroids are randomized. Some of the Unreal Engine features I use, like skylight, volumetric cloud and exponential height fog, do not look good from space, or they create transparency sorting order issues. But you can animate them being enabled or disabled using a timeline, so in the cutscene I will enable and disable the features as needed. The Ultranova cutscene will also have footage from inside the spaceship, so I have modeled a section of the interior. In my video called Turn Boxes into Spaceships, Making Ultranova 3, I showed how I planned out the spaceship by designing modules and thinking of something semi-realistic that would be needed on a spaceship. This makes it a lot easier to model the interior because I know the size of the command deck and I model corridors and interior maintenance rooms where some of the intro will be taking place. I will use a combination of emission light sources and fog to get an interesting look inside the Reaper spaceship. For the machinery, I created a new texture containing boxes in red, green, orange, blue and yellow, and then I created a material that uses the frame count, or a parameter in Unreal Engine, to scroll the UV coordinates vertically. This way the lights of the machines will turn on and off as the UV passes through the different colored boxes. This is a simple way to animate lights, and the emission will make them bloom with the post-processing effects. I still have quite a lot of work ahead of me to create the intro cutscene, but I'm learning many of the Unreal Engine features on how to animate sequences with timelines, so I'm not too stressed about the time that it takes. It is such an enjoyable process, and I hope this video gives you a little peek into the development of Ultranova. You can support me by wishlisting Ultranova on Steam and as a patron on patreon.com/Infencia. Don't forget to give it a thumbs up if you liked the video and subscribe if you want to follow the development process. Until next time, have a great one and I'll see you then. Bye for now.